Hello, hello, everybody. Welcome to Office Hour 24 of the World Quant Data Science Unit 1 course. My name is Nicholas. I am a data scientist at the Data Incubator, and I can't wait to help you with your questions today. I see a lot of familiar faces here already. Grace, how are you? Degefa, good to see you. Innocent, good to see you as well. Florin is here. How are you, Florin? Good to see you. Yvonne is also here. We have the whole gang. And Mauro is also here. Hello, Mauro. And Navdeep, good evening to you. Florin really wants to do question 6. Well, we'll definitely have to do question 6 today. I see the Dark is back. Welcome back, Dark. It's been a while. Good morning, good evening to you all. It's a pleasure to see you guys. Okay, so I know today we're going to look at DW6. What other questions do people have? I see Eminem is here. Hello, Eminem. What other questions do people have besides the last question of the last mini project? Emmanuel is here from Kenya. Hello, Emmanuel. Good to see you. So the dark says that they copied my code line by line, but there's something still wrong with the grader. Well, it's hard to tell without seeing your code, the dark. So my advice would be, if you haven't already, post a question on the forum with all of your code, and that way we'll have a chance to look at it and we can troubleshoot it. In fact, if we have time in today's office hours, if you post it now, we should have a chance to look at it. Mauro wants to know, how do you read a table if you have a dynamic IP address? Um, I guess it sort of depends, but one thing you could do is you could look at using a package like Selenium WebDriver. Let me just quickly find yep, here we go. Okay. And Emmanuel is interested in z-scores and p-values. Beautiful. We can definitely look at that today. Okay, so we have DW6, we have the Dark's question, and then we have p-values and z-scores. Okay, we can definitely do that. But first, why don't we jump into, first things first, let's do question 6. All right, I'm going to go to data course and then data wrangling, mini projects, and DW. Arthur, that's a good idea about troubleshooting the dark's script. That's definitely a possibility for the problem. Okay, let me just run a few cells here at the top of the page. And I'll import some of the data that we need. And then I'll go all the way down here to question 6. Syed is here. Welcome, Syed. All right. Now, just as a recap, let's take a look at what we've done so far. So the first thing we did is we had to identify which BNF codes are rare codes. And in order to do that, the first thing we did was we calculated the probability that any one BNF code would be prescribed. And we used the N-unique method, which you can do on any Pandas series. And then in order to figure out the rates of prescription, we took the value counts of BNF code, and then we also divided it by the total count of BNF code. And then we created the number of rates, then we created a mask, which was for rates that are below this probability, and this comes back to our p-score, the 0.1. And then we put that mask into our rates series. We got the index because we needed the BNF codes. And then we created a new column. We used that information to create a new column in the script's data frame, which was the rare column, and it told us whether items are rare or not. Okay, so after that, we calculated the proportion of costs that originate from prescriptions of rare treatments by practice. What is all this stuff here? This is a bunch of stuff that we don't need. And we then divided it by the cost by practice for all treatments. And then we also did a little bit of fill NA at the end. I'll delete this here. And then once we had that information, we calculated the z-scores for each practice. So we took the difference between the rare cost proportion and the total cost for rare, and then we divided it by scripts.sum. So we ended up with, let's check this out, relative rare cost. So let me actually run all these cells. Okay, so now we have the z-scores here. Now, the dark, keep in mind that I can't actually see, there we go. All right. For people that want to know, we'll get to this in a second, but this will be the dark's question, and we'll get to there in a moment. All right. So back to DW. So here we have a series, and the index for the series is the practice code, and then the data or the values for the series are the z-scores. Or excuse me, this is the difference, the relative rare cost proportion. And all right, we finally got there. So next, the question is, how do I take this, how do I take my relative rare cost proportion and how do I find the standard deviation? So I have this series and I need to find the standard deviation. What do you guys think the best way to do that is? I could do something like describe. Oh, excuse me. Hold on. I could do something like describe, and that would give me a lot of information, and I don't need all that information. So if I just want the one little bit that's the standard deviation, I can do what Yvonne is suggesting and do STD. So that'll give me the standard deviation, and I can save that to the variable standard errors. So if I look at standard errors, oh, excuse me, if I look at standard errors, it's a single value, so it's a float. So here's the standard error. So I have the standard error, and then I have the relative rare cost proportion. And so now I need to calculate the z-scores. So how can I calculate the z-scores if I have the relative rare cost proportion and the standard error? Yvonne is right. I can divide them. That's a great answer, Yvonne. So what I can do is I can take the standard errors, or excuse me, I can take the relative rare cost proportion and I can divide it by the standard errors. Now, let's just see what this looks like. Let's run this line of code and see what we get. So I've run the code, and then I'm going to look at the head, and I have a series here. I have a series here, and what I eventually want to have is a bunch of tuples with three things in them. The practice code, the practice name, and then the z-score. So I want to know how I can get all of these things into one data frame. I want to get them into one data frame first, And then I should be in good shape. So I have this series and I want to turn it into a data frame and also add some information to it. So what do you think the best way to do this is? Florin's got some ideas about iter values. I think those will come in handy maybe in one step, but I think we're missing a step. So I need to merge. Yvonne is right. There needs to be some sort of merging going on maybe. But then I'm going to have to deal with repeated codes. Some sort of join, possibly. Well, here's a question. Here I have a series. How can I turn it into, let's say, a data frame? Also, let's keep in mind, I believe we have somewhere earlier in this code, I think it was question 5. No. It was in question 4. Yes. In question 4, we created a variable, or we created something called unique practices. Yep, here we go, unique practices. So we have all the information we need. We have unique practices. And then we have relative rare cost. We can do it like you guys say, to frame. Now, one thing we could do is you guys are absolutely right. We could do a merge, which I think would be a fine way of doing it. There's nothing wrong with that. But I'm thinking I have an idea that might be helpful. So what I'm going to do is just keep in mind that we have relative rare costs. And if I have the relative rare cost and I put in the name of a practice, it's going to return the z-score for me, which is pretty cool. And what I could do is I could do something like unique practices z-score equals unique practices dot index apply, and I could create a lambda function. So I could go lambda code, and then just say return the corresponding code from unique, oh, excuse me, from not unique practices, from relative rare cost. Relative rare cost prop code. Let me see if this works, and then let's walk through it. I didn't think so. Let's see here. I could do the following instead. So here's what I could do. I could go unique practices, reset index, in place equals true. And then if I look at unique practices, and by the way, we could definitely do a merge here. It wouldn't be a problem. I'm just kind of interested in doing it this way to show you a different way of doing it. So now I have unique practices looks like this. And what I could do is I could go, let me divide this code up into a few, well, let me just put it down here below. Okay, so I could do unique practices code, apply lambda, let's say lambda x, and then relative rare cost proportion x. So what I'm saying is look at the code column, and then whatever answer or code number you get, then look for the corresponding, then go to the relative rare cost series, look for that code in the index, and then return the value associated with that code. Hold on. Why, there's a type error here. Let me see here. Key error 81111. Hold on, hold on, hold on. So I'm going to go to relative rare cost dot head. Index. That should work. So unique practices z-score equals unique practices. I'm just doing this for my own clarity here. The syntax shouldn't make a difference. Apply lambda x, relative rare cost x. A string object cannot be interpreted as an integer. Why is it doing this? Key error. Hold on. Hold the phone. I think I know what the problem is. Hold on. I think I've got it. Let me think here. Relative rare cost prop A811. Okay, I know what the problem is that there are keys in unique practices that are not in the relative rare cost proportion. So in fact, we need to do this the opposite way. Okay, let me redo it and I'll show you guys what I mean. So the first thing I'll do is I'm going to recreate unique practices. And then I'm going to delete all of this. Good. So next, I have two things. I have relative rare cost prop. Okay. And then the other thing I have is unique practices. Okay, great. All right, let's start over again. Let's just pretend the last 2 minutes didn't happen. So here's what I'm going to do. We have created our relative rare cost proportion. It exists now as a series. What I'm going to do is the code that we use to create this series, I'm going to add something to the end of it, which is going to be reset index. I'll rerun that cell, and then when I look at the head, I now have a data frame. And in that data frame, there are two columns. The first one is the practice number, the code associated with each practice, and the second is the ACT cost, which actually is z-score in this case. But don't worry about the name. One second. Okay. So here we are at relative rare cost proportion, and we've turned it into a data frame where we have the practice number and the z-score. That's the first thing we have. The second thing we have is unique practices, which is a series. And if I wanted to access the name that's associated, keep in mind that a series has two parts. It has the index, which in this case is the practice code, and then it has this value, which in this case is the name of the practice. Now, if I wanted to say look up the name based on the code, what I could do is use a square bracket, and then I could enter the number. I would enter it as a string, and so I see that the first row here is A81005. If I type that number into unique practices, it'll tell me Springwood surgery. Is everyone with me so far? Okay. Florin, do I have you back? I lost you for a second, but are you back? So the code for unique practices, Emmanuel is asking. I'll copy and paste it right here in question. I'll put it right here. We take practices and we group by code, and then we have the name column, and then we get the min, which means we're just getting the alphabetically first one. So what I can do now is I can add a column onto my relative rare cost prop. So I'm going to call relative rare cost prop, and I will call this column practice name. Practice name equals, and I'm going to say this column will be equal to the practice column in the same data frame, but you need to apply something to it. So we're going to apply a lambda function. So I'll say lambda code. And then here's where I'll add the unique practices series, and I'll put the code there. So what am I doing? I'm creating a new column in this data frame. The name of that new column will be practice name. And what I'm saying is go through the practice column first. For each code you find, look in the index of the unique practices series and return the name associated with that index. So this is sort of like doing a merge. I mean, in the end, it's basically like doing a merge. And Florin is asking, what is this backward slash? You can use this in Python when you want to have a line break, but you don't actually want it to read as a line break. So the code should be written like this as a single line, but since you guys can't see it, I want to break it up into 2 lines. So I'll use this backward slash, and that just means there's not actually a line break here. Ignore this line break. Treat this as one line of code. Okay, so it's just for, you're correct, Shrisail, it's just for visibility. Okay, I just realized something. I should actually be doing this not with the relative lost crop, blah, 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 not with the relative lost cost prop, but rather with the raw score, the rare scores. Let me just, I'm actually want to work, it's the same code, but it's just here on rare scores. So I'll take rare scores, I will reset the index. Apologies for the confusion, guys. And then what I will do is I will take my raw scores and prepare it there. So I will run these two cells. Whoop, type error. Hold on one second. I just need to rerun the cells here. Okay. Okay. And so if I look at the rare scores head, I now have all the information I need. I have practice, account cost, and practice name. So I take the rare scores series that I've made, I make sure to reset the index, and then I add the practice name column onto the rare scores. It's a data frame. And I do that by using this lambda function that will look up the name of the code in the unique practices series. And that gives me these three columns. Any questions at this point? Shrisal says, no, sir. Please, Shrisal, you can call me Nicholas. Don't worry. I won't be offended. Florian wants to know, do we have a possibility to not remove the practice for not using the apply method? I'm not sure I understand your question, Florian. Could you maybe restate it? In the meantime, I'm going to do, could we avoid removing practice earlier? I'm not sure about that. I don't think so, because we wanted to do some specific calculations with the z-scores and all of that, and then we put the practice name back. And the reason is because we're using the practice code here, basically as our organizing, as our organizer, as our group by. And since there are some slight differences between the practice names and the practice codes, we have to we have to choose one. So we start with the practice code, and then later we just add the name back in. And then I'm just going to do one last little bit of housekeeping here. I'm going to go rare scores equals rare scores, and I'm going to reorganize the columns so that it's practice, um, practice name, and ACT cost. Okay, beautiful. And now I need to get all of this into a list of tuples. So how am I going to get this into a list of tuples? So Florian wants to know, how did I know if the code would be associated with the correct practice name? Good question. So the way that I knew that is when I made the original list of unique practices, I grouped by code, I looked at the name column, and the instructions told me to take the alphabetically first name. And so when I put the min method here, what it did is, in the cases where there was more than one name associated with a given code, it would give me the alphabetically first one. And I see that Ivan has already taken some code and put it in the chat, so I'm going to paste it in myself. And for those of you that are joining office hours, say for the first time, keep in mind that if I have a data frame like rare codes, I can use the values attribute to get, let's do this, to get a list of lists. So it's going to give me a list of lists. Oh, excuse me, rare scores, rare scores. It's going to give me a list of lists where each sublist is a row. And I can turn a given sublist, for example, I can take a given array here and I can turn it into a tuple, which is what I want, by wrapping it in tuple. So that's how I would do it. And there's one other important thing we need to do. You're absolutely right, Florine. Tuples are unchangeable. That's a good thing about them. I also need to make sure that we're doing the top 100, and it needs to be sorted. I need the top 100 z-scores. So let me finish this answer, and then I'll come back and I'll start with apply. So don't worry, Emmanuel, I won't forget. So I'm going to go rare scores, sort values by ACT cost. You're absolutely right, Grace. And then it would be ascending, right? Ascending equals false, and then in place equals true. There we go. And if I look at the shape here, I have 856. I don't need all 856. So what I can do is I can create my rare script, my list comprehension, and at the end of it, I'll just say, give me the first 100. And so if I look at rare scripts, oh, I'm sorry, it should be rare scripts. If I look at rare scripts, I look at the first, well, if I look at the shape, I'm sorry, this is a list, so I need to look at the length. Got to remember your data types. It's 100 long. And if I look at the first 5 items in the list, no, this is not right. Let's see here. It seemed to have split everything up. Good, excellent. I'm glad we checked. Oh, I'm sorry. This is not rare codes. It's rare scores. 99 times out of 100, if you have a problem with your code, it's because you're confused about the variable names. So I'll look at rare scripts, and I'll look at the first 5 values, and there we go. I have the name of the practice, or the code for the practice, the name of the practice, and then their z-score. So I can see that these 5 practices happen to be making a lot of their money from prescribing exotic or rare treatments. And now, the moment of truth, I'm going to put it through the grader, and I'll see what I get. And my score is 1.0, so it worked. Okay, so we went over a lot here, and I had to move some things around. So what I'm going to do is I'm going to restart my kernel, and I'm going to take everyone through it step by step. Okay, so bear with me while I just run a few of these cells. And once that is done, I will go back to the screen and let's do it again. Not do it again, but let's review it. Okay. So the first thing that I did was I found out which codes are associated with rare treatments, and I added a rare column onto the scripts data frame. From there, I created a series called rare cost proportion, which showed the proportion of costs that originate from these rare treatments for each practice. Once I had that information, I calculated, so next I needed the z-score. And in order to do that, there are a few sub-steps. So the first thing is that I calculated the relative cost, right, as compared to all across all the practices. So let me rephrase that. The cost per practice versus the number of rare treatments across all practices. Then I also calculated the standard error for relative rare cost proportions. And then once I had those two things, my relative rare cost proportions and then my standard errors, I divided relative rare cost proportions by standard errors to get my z-scores. And I also reset the index on that series so that it became a data frame with two columns, the practice column and the z-score column. I then added a third column onto the data frame where I used another series called unique practices. And what I said is go through every row in the practice column and look up the corresponding name in the unique practices series. So all of a sudden, my two-column data frame became a three-column data frame. Then I had to worry about the formatting. So I reorganized the order of the columns, and then I sorted the values by the z-score. So now everything was sorted, and my data frame looked like this. And then I took that data frame and I turned it into a list of tuples, and I took the first 100 values in that list of tuples. And that left me with my data frame went from something that looks like this to a list of tuples that looks like this. And then this is the information that I ran through the grader to get my score. Okay, I hope that was a clear summary. I see Arun has joined us. Hello, Arun, good to see you. Shrisal is saying, are there any tips about how to keep track of the variables in these big coding problems? My only piece of advice is make sure that you're using different variable names so that at the very least you can keep track of them. Don't keep writing over the same variable names over and over again. Otherwise, you'll lose your mind. So it's a little hard with this last question, but because we were using different names for everything, we were able to track down the problem. Great question. Okay, any questions about this last challenge in the last mini project of the course? So El Arsi, El Asri, and Tolu are asking about office hour videos. So what I'll be doing from now on is every Tuesday and Thursday, I'll be updating the websites with the new office video links. So as soon as we're done here, I will update the links on the schedule tab of your course page, and the new links will appear. Okay, so all of these live links will be replaced. So that'll happen now every Tuesday and Wednesday. So Abdulhamid, just wait for me, and then I will get that stuff to you. Let's see here. We have 5 minutes left in office hours. Within the next hour, everything should be updated. And I really, really love Innocent's comment, right? So I'm just going to repeat it. But their takeaway from number 6 is to break down the question requirements before you write any code, because it'll save you a lot of time and headaches, and it'll make everything easier. That is absolutely true. You know, we as coders, sometimes we just want to jump right into the problem, but it definitely makes sense to take some time and think about it before you jump in. Great point. Now, we have about 5 minutes left, so I think this would be a good chance to work on some of the um, statistics questions that you guys mentioned at the beginning of office hours. I can't remember who mentioned them, but I just want to go over a few key terms. Okay, so let's say I have a distribution. Let's say it's a distribution of people's heights. Oh, wait, hold on. Wrong. Oh, no, wait, hold on. Okay, so let's say I have a distribution that is going to show me the heights of all the people. I'm in the United States, so let's just say the United States. And I'm going to say the mean of the sort of the average height is going to be somewhere around 5'7", or in centimeters, that's something like 170 centimeters. And the distribution of heights is going to look something like this. That doesn't look very good. Imagine this is a little bit more symmetrical than it is. Now, the mean here is going to be 170 centimeters, and you can see that most people are here in the middle. Most people are in the middle, but there are some people that are especially tall, and there are some people that are especially short. And keep in mind that I'm just going to say that this distribution is called a normal distribution. Sometimes you might hear the term Gaussian distribution. And the interesting thing about a Gaussian distribution is that if you look at the standard deviation from so if you look at the standard deviation, let me think about this here. There we go. If I look at the standard deviation, if I look at within one standard deviation, one standard deviation away from that mean, that's going to account for about 68% of all people. And then if I count two standard deviations away from the mean, that's going to account for 95% of all people. And then finally, if I count three standard deviations out, that's going to be 99.7. Okay, why is this important? The reason that this is important is that what is a z-score, I guess, is the question I'm trying to answer. And so a z-score is the number of standard deviations that your observation is away or distant from the mean. So if I have an observation that's right here, like some very tall person, I can count the number of standard deviations away they are from the mean. In this case, it's about, say, 2.5. That's their z-score. And that basically tells me how far away they are from the norm. So that's what a z-score is. And when we talk about, probabilities, like a little p, a lowercase p, often what we do in statistics is if we're dealing with a normal distribution and we find that something is more than 2 standard deviations away from our mean, it suggests that in fact our observation is out of the norm. It's abnormal. So if I have a pharmacy or a medical practice that is prescribing that the rate at which they prescribe rare treatments is more than 2, has a z-score of more than 2, it means that they are way out of the normal range for prescribing rare treatments, which makes me think that they're not a standard practice. They're not a normal practice. They are deviating from the norm and something is going on, right? The chance that they are actually normal at 2 standard deviations, well, it's like 5%. If it's 3 standard deviations, it's less than 1%. So I know there's a very small chance that this measurement is due to just randomness, and actually there's a phenomenon happening that I need to address. So I hope that that's a quick summary of some of the z-scores and of probability and of distributions. It looks like we ran over. I'm sorry, sorry, sorry. But I hope you all have a wonderful weekend. And for those of you whose questions I was not able to address, I promise that we will address them on Monday. For those of you that need the links to office hours, I'll upload them right now to the website. For those of you that are interested in the darks question, it is right here. I encourage you to look at it and help out. And for those of you that are looking for the What's Up link, you can search in the forum and there should be a What's Up link in there. Okay, so everyone have a wonderful weekend, and until we meet again, happy, happy, happy data science. Bye-bye.